Hello, everyone. Today, we are going to explore a fascinating natural language processing case study. We are designing an LLM, a language model, specifying for the emotion detection from text, and our test case, the simple phrase, good morning. Okay, so I'll repeat the test cases, the simple phrase that is good morning. So we are creating an LLM for that, for our NLP case study, natural language processing. So you might think good morning sounds positive, right? But let's see what happens when we analyze it properly using the NLP properties. So our main goal is straightforward. We want to analyze short text inputs and infer the most probable emotion class. We are working with three emotion categories, okay? And that is the positive, negative, and the neutral. Because as per Aikman, he's a psychologist, very famous psychologist, and his research has found out certain emotion classes where there are six emotions, say fear, anger, disgust. These are all which are seen emotions, right? And there is one more emotion that is neutral. So people might say that there is no emotion in the text good morning, but instead of the answer no emotion, one of the answer can be neutral. So this we know, but how the LLM is created? So three attributes for this emotion class is defined. Whether a person who is saying good morning. So see, when you have an audio, you can feel the audio, whether the person speaking is in a positive mood or negative while saying good morning, okay, enthusiastic. When you see a person, then also, even if you don't hear good morning, you can still find out. But when a text comes in, okay, with just simple good morning, right? So we don't understand whether it's positive, negative. So the answer can be no emotion, but my answer would be neutral. But to speak the neutral from the LLM, okay, like if you question this to the chat GPT, okay, how it internally frames and using NLP, this we are going to look forward in this particular session. I hope you'll enjoy this. So let's start with the first component, the lexical analyzer. So what does it do? The lexical analyzer breaks down input text into valid lexical units, basically meaning words. Okay, so it maps these words into lexical categories and attaches the features like sentiment and usage usage type rather. Okay, so what type are we using? We are using a rule augmented dictionary based lexical analyzer. I'll repeat, we are using a rule augmented dictionary based lexical analyzer. See, if you find this video fast, then you can rewind and look again, okay, or a particular text, you can just um, rewind it. Now, why? Because it is interpretable. Okay, why this type we are using in the lexical analyzer? Because it's interpretable, compatible with foundational NLP concepts, and works really well for short text. So whenever I teach, I always tell my students, first focus on why. Why are you using lexical analyzer? Just because it is a topic in the NLP or it is put in the syllabus? No. Okay. Why it is used? What's the purpose behind it? So that it's very simple to, make forward the deep concept to be used, and you later don't regret, okay, you using this technique, okay, because there are a lot of techniques which you can use to solve your problems. So how does it work? We have a lexicon. They think of a smart dictionary, okay, and each word is stored with multiple attributes. The word itself, it's part of speech, okay, that is POS, its sentiment, and its usage type. So for example, a good adjective is an adjective with positive sentiment, but it's tagged as a greeting modifier. Morning is a noun with neutral sentiment, tagged as a time expression. So here's the key insight. When we analyze good morning, we get good adjective. Good implies, okay? Good implies, the rule that follows is the good implies adjective, comma, positive sentiment, but greeting usage. And what does morning implies? Morning implies noun, neutral sentiment, okay? You can see here, neutral sentiment, and time reference, correct? So the token analyzer, the next component, what after the rules are formed, okay? So we have a lexical analyzer. We identify the components, we identify the lexicon in specific in a table format with these attributes. We form the lexical rules out of this study. Okay, so if you have learned DBMS, that is database management system. Okay, this subject is what I'm teaching right now to the PG student. Okay, but the postgraduate students might have done their database management system. So in the tables, okay, we have functional dependencies in the form of rules. Okay, the same thing which we are calling it as lexical rules. Just the name is a bit different, but the concept is the same. So you can just revise those in case you have forgotten. So next part would be the token analyzer. So what's the strategy is, why token analyzer matters in LLPM? Tokenization determines our vocabulary size, how we handle unseen words, okay, and morphological generalization. So what type of, what type we are using? We are using a Subword based token analyzer inspired by word piece and a BPE, correct? Um, what is BPE? It is a byte pair encoding, right? So we use this technique. For example, for good morning, we get tokens good and morning, right? And these words are common, so no splitting needed. But if we had an unseen word like happiness, okay, so it would be split into happy and ness. So this makes our model more scalable and robust. This is what is explained. So now the next part, the next phase would be the grammar design. So, these are the steps you need to understand. And likewise, you can create LLM for different text. Okay. For example, this case study is for good morning. You can take it for how are you and see what ChatGPT answers. You design your LLM using these steps and see what you answer. Okay. So this is called an exhaustive approach. In our previous video, we had discussed about the technique from exhaustive to heuristic. So you can go through that video, okay? That will be beneficial for you. We have explained the multiplication using that particular case study. So this is an heuristic approach where using these steps, okay, you can form an LLM, and that's the heuristic approach for any text which be given to the ChatGPT. Okay, you're not going to create text for good morning different, how are you different. You will create an LLM. An LLM will take any input, follow these steps and give you the output, correct? So going forward, now let's talk to the grammar design. What type of grammar? We are using a context-free grammars or a CFG, correct? Enhanced with functional tags. So our grammar rules, correct? It looks like a sentence can be a greeting. Greeting consists of an adjective plus time noun. Adjectives include good, pleasant, happy, and time nouns include morning, evening, and night. So when we parse good morning, so the next internal phase of it is grammar parsing. So when we parse good morning, we get this tree structure because we are using the CFG, that is context-free grammar, which uses a tree type of a data structure. So again, if you are a PG student or a UG student learning NLP, you might have learned being a CSC background about data structures. So we have got stacks, queues, linked lists, trees, graphs. So basically CFG is using, if it's a closed graph, that's called a graph typically, but it's an open graph, then it's called a tree, correct? So we parse good morning as sentence, then greeting, then adjective, good, and the time, noun as morning. So what does this tell us? This grammatical structure strongly indicates a conventional greeting, not an emotional assertion. So this is a pattern, not a emotion. So you can just join me on my lecture series in machine learning, where I always say that machine learning is nothing but you identify a pattern, okay, and convert it into an algorithm, where algorithm in computer engineering, any programming language, is nothing but the loops and the if then else. Okay, you can just look forward to the previous lecture just posted last week, and in that this is also explained in short. So machine learning is identifying of a pattern. Once you identify a pattern, then you can use the computer, its strength and the machine learning, convert it into heuristic approach or an algorithm, and you can just reuse it like an LLM. So previously we wrote algorithms, to reuse. Now the bigger concept is LLM probably. Okay, because we are actually be making the AI more like a human, and that's all about NLP in fact. So the language model LLM also uses a probabilistic it uses a probabilistic language model. Okay, so what does it do? It estimates the probability of a sentence given its usage type. Okay, so for example, P, this is the P probability we are putting input as sentence. Okay, and it estimates the probability of the sentence given about the usage type. Okay, so learned from the, now see what it has it learned from the corpus statistic large text data sets. The model has learned that good morning has a very high probability of being a greeting. It has a low co-occurrence with actual emotion labels. So statistically, good morning patterns with greetings and not emotional expressions as such. This is what the inference says. So the emotional inference, now we reach to the decision layer, emotion inference, okay, where feature vector construction, okay, FVC, feature vector construction. We extract these features where we say that greeting pattern is equal to 1. Okay, that means yes, it matches. It is emotion words is equal to 0. That means no explicit emotion words, okay, in the sentence. Then third category is the sentiment modifiers is equal to 0. That means it's not present. And sentence length also is needed. That is equal to short over here. So we need not, split mode like we said about the happiness, okay, happy and ness said previously. So statistical decision rule, we calculate emotion is equal to argmax and P emotion oblique features. So what does that mean is we find the emotion class with maximum probability given these features. So what's the result? The result is neutral. Even though good is a positive word in this context, okay? Good morning is classified as neutral because it is a conventional greeting, not a emotional sentence. Now see, already we had defined this as a human, but here we defined these steps, how we have created an LLM, and we got the answer like a human. And that's correct also. Okay, so the complete pipeline, let's see the complete technical pipeline in action. Fine. So the first step is input text is equal to good morning. Second step is lexical analyzer. It processes, the lexical analyzer processes it with dictionary and rules. Then third step is Subword token analyzer. It creates tokens. Fourth step is grammar-based parser that applies CFG rules. Okay, you can take a homework where you can see the CFG type of data structure in detail so that you understand how the CFG works. And fifth is, because if I go and explaining that subtopic, we'll be losing the objective of this particular session. So I would request you to do that as well. The fifth step is language model estimates probabilities that we have done. The sixth step is statistical emotional classifier that makes the decision, okay, based on the rules. And last but not the least, the seventh step is outcome, okay, that the detected emotion that is termed as finally neutral from the above steps. So this is how a modern LLM processes even simple text. And the case study here, text was good morning. So why this matters? Okay, why is this design important in NLP? So it demonstrates the need for NLP. I mean to say that emotion inference requires understanding context. Okay. Second is It demonstrates issues and complexity. So basically, words have different meanings in different contexts. Okay, so we need to understand that as an intelligent, like humans understand the sarcastic way of saying. But when it comes to text, you have to understand in between the lines in the text also. Correct? It becomes more easy while analyzing audio and video. But trust me, the text is a very simplest form of multimedia, right? We have five multimedia components as described in my earlier videos in detail: text, image, audio, video, animation. But text is the most widely used multimedia component, and it requires a lot of human touch to understand in between lines in a much more smarter way. So machine, it can be utilized more to understand that. But of course, if your LLM is designed in a proper way, the outcome is right. If the LLM is complex, maybe you can add to more complexity. So it needs to be very, very thought provoking. The third demonstration of the NLP is language modeling. So probability estimation, it helps us in making decision, okay? Because there is imprecision in the data, right? We always cannot say it's just good. It can be just too good. It can be just okay, good type, you know? So that also you have to analyze things to make decisions. Fourth type of application where it demonstrates, NLP demonstrates, is the grammar-based model. So it structure this grammar CFG, that he discussed, that it uses a closed graph, which is called as a tree, in case it uses graph as well. So this type of model structure helps detect pattern like greetings, because you suddenly bifurcate, classify, so you understand in a very precise way that time. So I would really tell you to study CFG in detail and take this case study in raw CFG. Huh? Since you have already learned TOC in your UG program and also analysis of algorithms last semester. So you can just try this. It would be more interesting and developing an algorithm for the same. And it's basically a modeling, right? So statistical modeling, the last application I would like to highlight here, it demonstrates NLP demonstrates statistical modeling, where we use data, to classify emotions accurately. Okay. So now why this emotion word is coming here? Because the question to the ChatGPT was that if somebody has tested me just good morning, what would be the emotion which is incorporated as this? So if you have missed this point, while creating the LLM, and that's why the emotion classes had come into picture. Okay, please, if you've not understood or skipped this, just rewind and go through again. It would be a good revision as well to all the steps. So this isn't just about good morning, it's about understanding how machine process human language. Okay. So I would like to summarize our proposed LLM architecture, which employs a dictionary-based lexical analyzer, a subword tokenization, a context-free grammar parsing, and statistically language modeling. So all of these work together to correctly classify the greeting good morning as a neutral emotional expression. So the key takeaway, okay, of this particular session is the context matters. So just because a word is positive doesn't mean the entire phrase expresses a positive emotion. I'll repeat it. It's very, very important, because this is the key takeaway of this particular LLM and the session is that context matters. Just because a word is positive doesn't mean the entire phrase expresses positive emotion. So good morning is a social convention, a greeting pattern, and LLM is smart enough to recognize that. This is the power of natural language processing in action. So thank you for watching and listening patiently. If you have any questions, please leave them in the comments, or you can email me in the email ID in the description box. I would like to thank my student scholar Sanjana, who took this effort, to analyze this LLM with me. as a homework. And the key terms to emphasize, again in short: key analyzer, tokenization, context-free grammar, CFG, probabilistic language model, feature vector, sentiment versus usage context, greeting patterns, statistical classification, argmax, corpus statistics. So good luck with this video. Thank you for your patience listening again. This is Dr. Aisha Butalia signing off from this session.